So this is the triple then higher contingency paper that was released in 2022. So the first question is asking you to work out dectane has a boiling point of 174. Name the fraction which contains dectane. It's going to be this one because that number would fit in that range there. When alkane is found in both diesel oil and lubricating oil, so we've got diesel oil here, lubricating oil here, give the number of the carbon atoms, so it has to be 20 because they've both got 20. Looking at this then, give the fraction where it's greater, okay? It's going to be this one because that is 50% bigger than that one. Okay, so that's C5 to C8. If you're looking at this, the greater the supply up to carbon 16, so the supply is greater, and then after that the demand increases, which relates to that box there. You're basically describing what the graph shows. This is a nice actually question. It has to add up to 20 and it has to add up to 42. So you add them two together, take it away from 20, and they're the numbers that you get. Poly kind of gives you the word there, so polypropene is made by polymerization. Nice question now about fire. So there's a fire in a woodland, and they're asking you to refer to 3 parts of the fire triangle and to work out what you would do to get rid of each part of the fire triangle. So you need to pick a part of the fire triangle to remove and then add the method in that you would use. So removing the fuel would use a fire break. Removing heat, you'd use water, and then if you're trying to remove the O2, you use beating. You could use add CO2, but it's a bit more complicated when you've got a large forest fire like this. So the raw material added in to the air to make sulfur dioxide, so kind of gave it away there. The oxide is oxygen, and the raw material here is water. Purpose of vanadium oxide is a catalyst that speeds up reaction, not reacting, reaction. Okay. Stage 2, so sulfur dioxide is there. Sulfur dioxide, so sulfur with 2 oxygens, and then balance it out. Looking at this then, state the trend as the percentage yield of temperature increases, so as the temperature increases, the percentage yield decreases. Give the temperature range to be used to obtain a yield of sulfur trioxide greater than 80, so that's going to be somewhere between 300 and 500, because there's 80, so there's the values you're going to have. And then complete the equation for the reaction by giving the formula of oleum, so you're just adding these two together. So you've got 2 hydrogens, 2 sulfurs and 7 oxygens. Name the products formed. It's carbon and water. That's carbon, and then there's some water formed because the dehydration is taking place. Blank page. So this is a little bit more complicated than you would get on a foundation paper. So we've got magnesium on its own plus hydrochloric acid would make magnesium chloride plus the gas hydrogen. Okay. The next one then is iron nitrate plus sodium chloride. So that is a soluble-insoluble reaction that only triple scientists have to do. And then that gives you silver chloride, and you just look at what's left and what's displaced, so it gives you sodium nitrate. You've got zinc oxide then plus nitric acid, so that's going to give you zinc nitrate plus water. Same kind of thing here, copper carbonate plus sulfuric acid, because there's the sulfur there. Outline the 3 steps you carry out a pure sample of silver chloride from reaction mixture B. You want to filter it, then you want to wash and dry it, and then wash and evaporate it. Write the balance simple equation for the reaction taking place, so sodium hydroxide. Remember, you can find them in the table of ions. Hydrochloric acid you have to learn, sodium chloride, and then water. Nice little flow diagram here explaining how you would prepare pure copper chloride crystals using 25 centimetres. So this is a titration. This is a titration. So the titration, and there's a bit of the apparatus used in stage 1. Describe how a student would find the exact volume of acid needed to neutralise all alkali. Add indicator, add the acid drop right until the indicator change colour, and then you can record the temperature on here. Neutral solution obtained in stage 1 is not pure. Describe what the student must do in stage 2 to make sure the pure sodium chloride crystals are formed. Add acid and alkali at the same volume without the indicator. The indicator is what makes it impure. State what the student must do in stage 3 to obtain sodium chloride crystals allowed to evaporate. Then, ionic bonding, you have to show where they go, and then the charge. So 3 marks, this is really nice. So calcium had lost 2, so it becomes +2, and then each chlorine had gained 1, so they become negative. Then we are looking at doing a covalent bond where they would share. Okay, carbon's got 4, each hydrogen's got 1, and that chlorine had 1 to share as well. That's quite difficult for 2 marks. Okay. answers to the 6th marker then. So explain why calcium and calcium chloride have different bonding structures, okay? So you could have drawn by here if you wanted to, like a little bit of a diagram, because calcium is a metal, what it would have looked like. Potentially got a mark. You could have gone as far as to draw the bond in between that, but that was on the previous page, so you wouldn't have gained much from that, okay? So, calcium has metallic bonding as a metal. Delocalized free electrons move between the positive ions. Electrons move towards the positive terminal. Electrical current is allowed to flow between the electrons. Okay. Calcium chloride has an ionic bond, is an ionic substance. Solid cannot conduct electricity because the ions are not free to move. Ions become free when calcium chloride is molten or solution is dissolved. Okay. So there's more than 6 points there to get 6 marks. Again, a lot kind of going on in this flow diagram, which is all explaining how to electrise aluminium. So, give the chemical name for the iron compound, so it's iron 3 because there's 3 oxygens, iron 3 oxide. Give one reason why aluminium oxide is dissolved in molten cryolite, that lowers the melting point of aluminium oxide. Explain why the anode is burned regularly in place because it burns away, okay? The CO2 and the heat of it makes it burn away. Balance the equations, you're splitting up aluminium oxide into aluminium and oxygen, and then you've got 4 aluminiums there. Explain why most aluminium waste is recycled. Aluminium extraction is expensive, large amount of energy needed, so we need to make sure that we recycle and regenerate because we don't have a lot of aluminium going into spare because of the expense. This then is a lot of information to answer some questions. Okay, so you had to pick the answers to the boxes. Okay, so all the information was in the previous slide in terms of the questions. So aqueous conditions prevent chlorine from reacting with titanium. Sodium hydroxide and magnesium hydroxide are the 2 substances that are formed on the right hand side. Give the general formula of the alcohol formula, 1 mark there, nice easy 1 mark. Then it asked you to include state symbols for the reactions and products of forming ethanol and carbon dioxide from glucose solution. So you had to know that ethanol was C2H5OH and the carbon dioxide is a gas, and then balance it out. Give the general name of this type of catalyst, it's just an enzyme. That's quite a weird question. Okay, so name the isomer. It's got a methyl group coming off the 2nd carbon. So go 1, 2, 3, or I tell you what they would have done. He's gone 1, 2, 3. So you can go backwards. Okay, you want to get the lowest number. So there's a methyl group. That's a methyl group coming off the 2nd carbon. And you've got an OH group on the 1st carbon. Okay. Penton 3-ol is one of the isomers of C5H11OH. Draw the structure of pent 3-ol. So pent 3-ol is going to look like this. So 1, 2, 3 with a OH there. That 3 is just indicating where the OH is. So, information by here, kind of a diagram by here. Give one observation that shows the copper sulfate is in excess because there's magnesium powder left at the bottom. So all the copper sulfate has reacted. So nice diagram here. You had to plot the results from the previous page and then draw a line of best fit. That's a really nice straight line. So 2 for the points that you plot and then 1 mark for the line of best fit. Use the graph to find the mass of magnesium needed to form 18. So find 18, so it goes up in 2s, 2. Okay, so you need 18 of the magnesium. So, nope, you don't. You need 18 of the copper. So we're going to go from here, go across, and then go down. Okay, and that's 0.7. Students stated that 0.78 copper would be formed when 0.3 of magnesium is added. So if so basically you have to do like trial and error, stress how she arrived at this value. So 0.1 grams of magnesium is added, multiply that by 3, and you would have got that value, because that's what happens when you add 0.1 grams, multiply it by 3, you've got that. Then it says work out the moles. So they have given you a mass, given you MR values, so work out the MR over the mass, and that'll give you the moles, which is that by there. Okay, nice, easy, 2 marks. Use the equation below to calculate the concentration of copper sulfate. So it does say by here that there is a volume, okay, of water dissolved in the water. So you do 50 divided by 1,000 divided by the number of moles, and that will give you that value by there. Then a nice question that very similar to ones that we would have practiced in lessons. So calculate the energy needed to break the 3N bond. Okay, so they gave you the value for all of them. So they told you that was 2253. Okay, they then said that each of the hydrogen bonds is that. So the total of the hydrogen bonds is that. So all of that equals that. So take them away from each other, and that would give you the value for the N triple bond. Okay. Calculate the energy released when all the bonds in ammonia are formed. Okay. So you're relying on reactants minus products equals that value by there. Okay. So you're essentially saying that value by there, take away X equals that value. So rearrange your equation, and then you should have got X to be that value. For 1 mark, that was a lot of thinking. Describe the relationship between percentage yield of ammonia and the temperature. So, percentage yield is running along here, it's decreasing, and the temperature is increasing. So, percentage yield increases as temperature decreases. Okay, circle the most likely ammonia yield if this was carried out at 200. So, 200 atmospheres pressure is here, and 400 degrees. I lie, I've done that the wrong way round. So that's 200 and that's 400. That's the value we want there. So we're going to look at a value between 66 and 18. So it's going to be that value. Okay. Last little question then. So use the information provided to identify compounds A, B, and C. So straight away I can see this bit here about litmus paper, so I know it's ammonia. Okay, and then that's silver nitrate, and it gives white. So that's chlorine. Okay, that's the first one. Green flame then, that's copper, and then white precipitate forms with barium chloride, so copper sulfate. Again, lilac flame, potassium, and carbonate because it turns lime water cloudy. You've got this additional page if you need it. Make sure you put the page numbers down the side, and then you've got your table of ions and a periodic table if you need it.